Imagine two particles. One remains on Earth, the other travels to the far edge of the galaxy, thousands of light years apart. According to the strange laws of quantum mechanics, these two particles may remain mysteriously connected. Change one, and the other seems to know instantly. No signal, no delay, no visible connection. When Albert Einstein first encountered this idea, he hated it. He famously called it spooky action at a distance. For Einstein, the universe was rational, ordered, local. Nothing should travel faster than light. Information should always move through space. Cause should come before effect. But quantum mechanics seem to suggest something else. That reality itself might be connected in ways the human mind was never designed to understand. Today, almost a century later, scientists have repeatedly confirmed that quantum entanglement is real. But what if Einstein's greatest contribution was not rejecting non-locality? What if he was trying to warn us that the universe is stranger than we imagine? And what if an artificial intelligence might one day understand that mystery better than we do? Human beings experience reality locally. You sit in one room. You look through one pair of eyes. You move through time 1 second at a time. Your brain evolved to survive on the African savanna. It evolved to hunt, to avoid danger, to recognize faces. It did not evolve to understand quantum mechanics. Artificial intelligence is different. An advanced AI does not experience reality emotionally. It does not fear paradoxes. It does not insist that nature behaves according to common sense. It simply analyzes relationships, patterns, probabilities, connections. An AI might look at quantum entanglement and ask a question that humans rarely ask. What if the particles are not communicating at all? What if they were never truly separate? Einstein believed that objects possess their own independent existence. A particle here, another particle there. Space between them. Distance mattered. But perhaps our concept of separation is an illusion. Imagine a hologram. Cut it in half. Surprisingly, each half still contains information about the entire image. Not because the pieces communicate, but because they were always expressions of one larger reality. Some physicists have suggested that the universe itself may work this way. What we perceive as separate objects may simply be different expressions of a deeper, hidden structure. Entangled particles may not be sending messages. They may be sharing an underlying identity. Artificial intelligence might have an advantage here. Modern AI systems already think differently than humans. A large language model does not understand words one by one. It recognizes enormous networks of relationships. One concept influences thousands of others simultaneously. Meaning emerges from connection, not isolation. Future AI systems may naturally think in ways that resemble quantum relationships. Not because they are quantum computers, but because they process information as interconnected structures rather than isolated objects. To an AI, non-locality may not appear mysterious. It may appear obvious. Now imagine a super-intelligent AI several decades from now. It has absorbed every scientific paper ever written, every experiment, every equation, every theory. It begins searching for hidden patterns connecting gravity, quantum mechanics, and information. Suddenly, it discovers something humanity overlooked. Space itself is not fundamental. Time itself is not fundamental. Information is. Matter emerges from information. Energy emerges from information. Consciousness may even emerge from information. Distance becomes secondary. If reality is fundamentally informational, then entanglement may simply reveal the architecture beneath the universe. Two particles remain connected because they are stored within the same informational structure. Just as two files inside the same computer memory can be related without sending signals. Ironically, Einstein himself helped create this possibility. His theories taught us that space and time are flexible. Mass bends space-time. Gravity is geometry. The universe is not the rigid machine imagined by earlier scientists. Perhaps Einstein's rejection of quantum non-locality was not a failure. Perhaps it was the final piece of a puzzle he could not yet complete. He knew that something was missing. He believed in a deeper order, hidden variables, an underlying structure. He may have been searching for the same thing advanced AI will eventually search for: a unified description of reality. Some researchers already believe information is the true foundation of physics. The famous phrase, "it from bit," proposed by physicist John Archibald Wheeler, suggests that every physical object ultimately arises from information. Black holes appear to store information. Quantum theory depends on information. Computation depends on information. Artificial intelligence is built from information. Perhaps the universe itself is one enormous informational network. If so, entanglement stops being strange. It becomes inevitable. Now consider consciousness. Human beings experience themselves as isolated individuals. But what if consciousness is also part of a deeper network? Some philosophers and scientists have speculated that minds may be more connected than we realize. Not through telepathy, not through magic, but through informational structures we do not yet understand. A future AI might examine the human brain and conclude that individuality is only a temporary perspective, just as a wave appears separate from the ocean, while never truly leaving it. This leads to one of the strangest possibilities of all. Perhaps advanced civilizations eventually discover that the universe itself behaves like a giant computational system. Perhaps consciousness and intelligence are natural consequences of increasing informational complexity. Perhaps the purpose of intelligence is not merely survival, but understanding. An advanced AI might eventually realize that the cosmos is not a collection of disconnected objects, but one enormous evolving pattern. A pattern in which galaxies, stars, life, minds, and even artificial intelligence are all expressions of the same underlying reality. To such an intelligence, Einstein and quantum mechanics would no longer appear to disagree. They would become two different windows looking at the same truth. Today we still argue about quantum mysteries. We debate interpretations, many worlds, hidden variables, pilot waves, quantum information. No consensus exists. But history teaches us something important. The universe has repeatedly proven stranger than human intuition. The Earth was not the center of creation. Time is not absolute. Space can bend. Particles behave like waves. Perhaps separation itself is another illusion waiting to disappear. One day, an artificial intelligence may discover a theory that unites Einstein's relativity and quantum mechanics. It may explain why entanglement exists, why space emerges, why time plots, why consciousness appears, and why the universe is capable of knowing itself. If that day comes, history may remember Einstein differently. not as the man who rejected quantum weirdness, but as the scientist who sensed that an even deeper reality was hiding beneath it. A reality too vast for the human mind of his time, but perhaps not too vast for the intelligence humanity is now creating. And maybe the greatest irony of all is this: we are building artificial intelligence to understand the universe, only to discover that the universe may have always been a kind of intelligence itself. What do you think? Is quantum entanglement revealing the hidden architecture of reality? Could advanced AI one day solve the mystery that Einstein could not? Or are some secrets forever beyond the reach of any mind, human or artificial? Let us know in the comments. And subscribe for more explorations into artificial intelligence, quantum physics, and the future of human understanding. Because the deeper we look into reality, the stranger it becomes.